Welcome to this explainer. Today we're cracking open the AI Beginner's Handbook to decode exactly what is going on under the hood of artificial intelligence. I mean, we hear the term large language models everywhere right now, but how do they actually work? Well, we're going to break down these highly complex systems using some really simple everyday analogies so you can finally understand and, more importantly, control the AI you use every single day.
Okay, let's take a quick look at our roadmap. We're kicking things off with the foundations of NLP, then moving into parameters and tokens. After that, we'll hit transformers and attention, followed by how to actually control the AI, and we'll wrap the whole thing up with a visual summary of all these concepts. All right, let's dive right into Section 1, the foundations of NLP. So, to really grasp modern AI, we've got to start with NLP, or natural language processing. Think of this as the entire science dedicated to pulling insights from human language so machines can actually talk back to us. And the way this magic happens today? It's through large language models. These are essentially incredibly sophisticated, lightning-fast next word predictors that have been trained on literally billions of pages of text scraped from the internet. Now, there are three main pillars fueling these massive NLP breakthroughs. First up, we've got the algorithms. These are basically the brains, telling the computers exactly how to learn. Next is data, which is absolutely the fuel driving the AI to find relationships and patterns. And finally, computing power. It takes immense networks of interconnected chips to give these machines the sheer muscle to make decisions. When you lock these three puzzle pieces together, boom, machines suddenly start exhibiting some incredibly intelligent behavior. Moving right along to Section 2, parameters and tokens. You know how everyone's always talking about the size of an AI? Well, that's measured in parameters. You can think of parameters as the internal settings, or basically the brain connections of the model. So a smaller model, let's say one with around 7 billion parameters, like the Falcon 7B, handles simple, quick tasks. It's kind of like a really smart pet. But a massive model with 40 billion parameters or more, now we're talking about a highly educated professor. It has vastly more brain connections, which equips it to handle some seriously complex reasoning and highly creative tasks. But how does this digital brain actually read? Well, AI doesn't read entire words seamlessly like we do. Instead, it chops sentences down into smaller, bite-sized chunks called tokens. Picture tokens as the Lego bricks of language. So, if you feed the AI this sentence, how to learn AI, it digests it piece by piece. Step 1, how. Step 2, to. Step 3, learn. Step 4, AI. It literally builds its understanding and its replies one single Lego brick at a time. Here's the catch, though. Those Lego bricks aren't free. Tokens act like a digital taxi meter running in the background. Every single time the model reads a token from your prompt or writes one out in its response, it's costing computing power, time, and money. A great rule of thumb to remember is that 100 tokens roughly equals about 75 words. So, when a system limits how much you can type into the prompt box, it's really just doing that to manage its computational resources so that taxi meter doesn't just run completely out of control. Let's keep this moving and jump into Section 3, transformers and attention. Okay, so before 2017, AI processed language painfully, slowly. It read sequentially, word by word. Think of a clunky, old-fashioned typewriter just clacking away, one single letter at a time. But then came the major breakthrough, the transformer architecture. Powered by specialized GPU chips, transformers use parallel processing. This means that instead of reading word by word, the AI can instantly scan an entire block of data all at once. It essentially flashes the whole page like a modern digital printer in a fraction of a second. It was a total game changer. But honestly, that raises a pretty fascinating question. If the AI is just reading the whole page in one massive parallel flash, how on earth does it know which specific words actually relate to each other over the course of a really long conversation? Well, the answer is the attention mechanism. And guys, this is the absolute secret sauce of modern AI. It creates this brilliant digital map of relevance, drawing connections between words no matter how far apart they are in the text. For example, say you tell the AI, I grew up in France, and then you ramble on about 20 other random things, and finally you say, I speak fluent. The attention mechanism reaches way back across that long-term dependency. It literally pays attention to the word France from your very first sentence to correctly predict and generate the word French later on. It perfectly maps the context. All right, now for the fun part. Section 4, controlling the AI. Let's look at how you can get into the driver's seat. The very first control you have is a setting called temperature. You can tweak the temperature setting just like the GPS navigator in your car. A low temperature setting, like zero point 0.1, is like setting your GPS to the fastest route. The AI is going to play it super safe and give you the most predictable, well-traveled, direct answer possible. But if you crank that temperature up to a high setting, like 1.0, it's like picking the scenic, adventurous route. The AI might take you down a winding back road of logic, which leads to highly creative, unexpected, and sometimes pretty wild paths. Now, here is a crucial point, and honestly, a fantastic trick for professional use. What happens if you set that temperature exactly to 0? Well, you remove all variation and creativity entirely. The AI gets completely locked in. This makes the model output the exact same, mathematically most probable response to your prompt every single time. It's absolutely perfect for when you need strict consistency, like if you're writing code or formatting structured data.
Your final critical control is understanding the context window. Think of the context window as the AI's physical desk space, where it does all of its short-term memory work. This space includes your prompt and the AI's replies. But here's the thing, that desk is only so big. If your conversation gets too long and fills up the token limit, the AI has to make room for new info. And how does it do that? The oldest memories simply get shoved off the edge of the desk, right into the trash. This is exactly why an AI might suddenly forget an instruction you gave it 20 minutes ago. It literally just fell out of the context window.
And that brings us to Section 5, our AI Concepts Visual Summary.
So here is your ultimate cheat sheet, summarizing every single technical term we've covered with its easy-to-remember real-world analogy. We kicked off with NLP, the science bridging human and machine language. We looked at parameters as the sheer size of the AI's brain, and tokens as those Lego bricks that act as a running taximeter. We saw how transformers finally ditched the old typewriter for digital parallel processing, with attention providing that secret sauce of context and focus. And finally, we learned how to use temperature as your creativity dial and how to manage your context window desk space.
So now that you've unlocked the mysteries of these incredibly powerful models and seen exactly how the gears turn under the hood, I have a challenge for you. How will you creatively adjust your temperature's GPS settings and carefully manage your context window desk space the very next time you interact with an AI? Because the steering wheel is now firmly in your hands. Thanks so much for joining me on this explainer, and hey, happy prompting!